Okay, now I want to move on to questions which are asked, which are related to the curve, which are related to the graph. Sometimes you'll be asked that, or you may be asked. Sometimes you may be asked that. Find the gradient of the curve when x is equal to 3. The gradient, to remind you from the first lesson, the gradient is the slope of the line. So in this case, the gradient is the slope of the curve. So the question is saying, find the slope of the curve when x is equal to 3. So in this case, this is where x is equal to 3. If I draw a broken line up to this point, we can see that the corresponding value here is 6. Okay, so at this point, to find the gradient, we have to draw a tangent. A tangent is a straight line which touches the line or our curve at only one point. Usually, I always say that if we draw a tangent here, the angle which is on this side must be equal to the angle which is on this side, so that your answer will be accurate. I know a lot of students are clever enough to use differentiation to answer this question, but on your level, in terms of O level, you are not allowed to do that. That's why examiners don't show the working of gradient using differentiation. Okay, so in this case, I've drawn, this is the tangent. The formula which you must use to find the gradient is this. Since we are dealing with the Cartesian plane, we can use the formula which is m is equal to y2 minus y1 over x2 minus x1. This means the difference in y coordinate over the difference in x coordinate. Where are these coordinates coming from? Okay, to find the gradient of this line, you have to pick any coordinates on this line. Please take note, you pick any 2 coordinates which you can see on this line, this straight line, not on the curve, but on this line, which is the tangent. So you can choose to select 2 and 11, 2 and 11, somewhere here, the coordinate 2 and 11. Then you can choose to select 3 and 6, this point, 3 and 6. So when I use 2 and 11 and 3 and 6 to find the gradient, and I've said the formula is, let me write the formula clearly, m is equal to y2 minus y1 over x2 minus x1. So what we do is we just say x2, then y2. Why did I do that? This value is representing the x coordinate. This value is representing the y coordinate. Okay, so here we write x1 and y1. So we take our values and put them into this formula. This is equal to, what is the value of y2? y2 here is 6. So we write 6. And we say minus y1 is what? Is 11. So we write 11 here. Over x2 here is 3. And x1 is 2. So m is equal to, according to these coordinates, 6 minus 11 over 3 minus 2. And 6 minus 11 is equal to minus 5 over 3 minus 2 is equal to 1. Therefore, m is equal to minus 5 over 1. This is equal to minus 5. Our gradient when x is equal to 3 is minus 5. It means the slope of the curve when x is equal to 3 is minus 5. I shall repeat. The first step is to locate the point which you are asked to find the gradient at. Then draw a tangent at this point so that the angle here, this angle, must be equal to this angle. And pick any coordinates on this tangent and use the formula for gradient, which is y2 minus y1 over x2 minus x1, which means difference in y coordinate over difference in x coordinate. So use your coordinates and substitute them in this formula so that you will find that the gradient is minus 5. Okay, now we want to move on to the second question, which is asked, which is related to the graph, to this function. Right. You can be asked to attempt this question. Okay. Use your graph to find the roots of the equation. So, at this point in time, know that the roots of the equation is the same as the solutions for the equation. So you can be asked to find the solution of the equation x plus 3 and 4 minus x is equal to 0. Here, you have to know something. Right. To find the solution of this equation, you don't need to use the concept we did in terms of factorization or quadratic expressions, in terms of saying x plus either x plus 3 is equal to 0 or 4 minus x is equal to no. The question is strictly saying use your graph to find the roots. In other words, the question is saying use your graph to find the solution of this equation. So, to find this solution, we have to know something. The function is y is equal to x plus 3, then 4 minus x. This is the function. So, instead of remaining with y, here we have 0. So, in other words, this line has been joined with the line y is equal to 0. So that when you remove y here and we put 0, we'll arrive at this equation. So, to find the solution, to find the roots of this equation, this is the curve, this is another line. So, draw another line which is called y is equal to 0. Recall, in terms of the first lesson we did in terms of drawing straight line graphs. Right, the line y is equal to 0, remember, is the x-axis. So this is the line y is equal to 0. The solution is found where the function y is equal to bracket of x plus 3 and bracket of 4 minus x and y is equal to 0 intersect, and y is equal to x plus 3, 4 minus x. Intersect. So, what is the value of x is at this point of intersection? The value of x here is minus 3 and the value of x here is 4. Hence, the solution of this equation is x is equal to minus 3 or x is equal to 4. These are the roots of this equation. So the question which require you to find the roots is the same question as find the solution or solve this equation. Okay, this is our first example. So always know that you have to know that the solution is found where the line y is equal to 0 and this function intersect. So what is the value of x at the point of intersection? X is equal to minus 3 and here x is equal to 4. This is the solution. Now moving on to the next question of finding the roots. We can be asked to find the roots of the equation bracket of x plus 3 in bracket of 4 minus x is equal to 4. Again, we know that our function has been joined with the line y is equal to 4. So we have to draw the line y is equal to 4 and find the point of intersection so that we will find the values of x at the point of intersection. So our line here, our original curve y is equal to x plus 3, 4 minus x has been joined with the line y is equal to 4. So we have to draw the line y is equal to 4. And remember, the line y is equal to 4 is a horizontal line which crosses the y-axis at what? At 4. So we have to draw a horizontal line which crosses the y-axis at 4. So this is the point of intersection and this is the point of intersection. So we have to find the value of x at the point of intersection and find the value of x. So draw an arrow to indicate where the value of x is found here and where the value of x is found there. So the value of x, according to your graph, especially when you use a graph paper, if you find the value which is 2, 4 or any value which is close to this minus 2, 3 and somewhere there, you are in the right range. Again here, so we say x is equal to minus 2, 4 or x is equal to 3, 4. So this is the solution of this equation, bracket of x plus 3 and bracket of 4 minus x, which is equal to 4. So this is how you attempt this question, which is related to the roots of the equation. Or if you are asked to solve this equation, don't ever try to solve it using that concept of saying either x plus 3 is equal to 4 or 4 minus x is no. The question is okay. Now we want to move to another section of finding the area under a curve or the area bounded by certain boundaries, so that you'll be able to attempt this kind of equation. Okay, here's the question. Use your graph to find the area bounded by the curve x-axis, y-axis, and the line x is equal to 1. Use your graph to find the area bounded by the curve x-axis, y-axis, and the line x is equal to 1. So take this information as boundaries, or take these lines as boundaries. Right, we are told of the curve and the x-axis. This is the x-axis, and the line x is equal to 1, and also y-axis. So the line x is equal to 1. Remember, it's a vertical line which crosses the x-axis at 1. So our area, remember, we are told about the curve, the x-axis, the y-axis, and this line. So the area which is bounded, which is surrounded by this line, which is surrounded by these lines, or which is surrounded by these boundaries. This is the area. This is the first step, to identify the area. The second step, to find the area, please take note of this. Find. Now, I was saying, to find this area, please note that you have to count the number of boxes which are on this region. A square of 2 by 2, note that has 100 boxes. So you have to know that here we have the first square, the second, the third, fourth, fifth, sixth, and the last part. So you have to count the number of boxes. Right. In this case, don't waste your time to count, like saying 1, 2, 3. Already you know that here we have 100, and we have 100, we have 100, we have 100, we have 100, we have 100. Just count these boxes which are on top of these exact squares. So if you count the boxes accurately, you find that the total number of boxes is 608. 608. We have 600 boxes. This is the first step. So to find the area now, you have to know the area of a single box. A single box. Okay, the area of a single box, in this case, you consider the length here, which is represent 10 boxes, and the length here is 1 unit. So the length of a single box is 1 over 10, and we say times here we have 10 boxes here, and the length here of 10 boxes is 2 units. So the length of a single box is 2. We say 2 over 10. Okay, so the area of a single box is 1 over 10 times 2 over 10. So to find the total area now of this region, you say 1 over 10 times 2 over 10 times the total number of boxes. So you say times 600 times 600, 608 times 608, and you find that the area is 12,16. 608, and you find that the area is 12,16 square units. Right, like this. So I've said 1 over 10, let me write it clear, times 2 over 10 times the number of boxes, say 608. So we get 12,16 square units. So this is the area of this region. I shall summarize what I did. I've first identified the area which is required of us to find I've determined the region which is required of us to find the area. So the area of this region is obtained by finding the total number of boxes here and multiplied by the area of a single box. So the area of a single box is 1 over 10 times 2 over 10. So to find the total area, we say 1 over 10 times 2 over 10, then times 608, and we get 12,16 square units. This is what we do when we calculate the area bounded by the lines which we are given, or the area under a curve.